So this is going to be our final lesson on simultaneous equations. Okay, I think you might actually find this one the easiest of the three. So and it will certainly consolidate your understanding of it. So if you find that you can do this one quite quickly, that would be great. Then maybe you could go back and try and complete one of the other two we've had on simultaneous equations, because tomorrow we're going to move on to a new topic. So far, all we've done is just sort of solve simultaneous equations when we've been presented with the simultaneous equations to solve. So it's already there. They're already in front of us, and we've just got to solve them. Now, what we're going to do today is sort of use them in a sort of a real life situation, really, where we use them to solve a problem. So we not only do we have to solve the simultaneous equation, we've got to construct the problem in the first place. Now, I just wanted to draw your attention before we get going to what it says on the scheme of work. It does say, if appropriate for the group. Now, obviously, we're a set 3, and so you know, it could be argued that are the simultaneous equations too difficult for a set 3? Well, I don't think they are. I think lots of you have got real potential. You know, you're good enough to be in set 2. So I think it's really important that we all appreciate this is a difficult topic, but it's well worth one that we try and get to grips with, because you know we don't want to be getting behind the sets above us if we can, because I think you know you're all going to end up doing the higher paper one day, so we're going to have to get to grips with these topics. But I just wanted you to realise that I do appreciate this is a difficult topic. So you know, not many of you are managing to whip through and get 100% on these, and I understand why. It's not easy. So looking at the Hegarty mass exercise that you're going to be doing, okay, it's going to be number 195. And what I've done here, I'm going to hook out the two typical types of questions that crop up. So I think number 1 and 2 tend to be a bit like this. So they just give us this fact. Find two numbers which when you add them up you get 17, but the difference between them is 1. So let's just go and let our two numbers be x and y. So what do we know? We know that when we add them, all right, when we sum them, we get 17. So there's our first equation. But we know that the difference between them is 1. Now, how do you work out the difference between two numbers? You take the smaller one away from the bigger one. Okay, so if we just sort of think of x as being the bigger number, we can say that x, when we take away the smaller number, we're left with 1. So just check you're okay where they've come from. The two numbers, x and y, when you add them up, you get 17. That's the top one. But the difference between them, so when you take one away from the other, you get 1. So there we have it. We've constructed a simultaneous equation. Okay. Now, I'm going to choose to eliminate the y's here. Okay. I want to get rid of the y's. Now, because the y's have got a different sign, right, different sign there, we're going to choose to add these two equations together, and that will get rid of the y's. So I'm going to add the two equations together. So x plus x is obviously 2x. Now y added together with a minus y, so y take away y is nothing. We've got rid of y, which is exactly what we wanted to do. So the y's gone, and then 17 add 1 is 18. So 2x equals 18. So dividing both sides by 2, we can see that x equals 9. Okay, now step 2. Step 2, as always, is you take one of the equations of your choice. I'm going to go and take the top equation. So x plus y equals 17. And I've just worked out that x is 9. So go and pop 9 in there. 9 add y equals 17. Taking away 9 from both sides, that must mean that y equals 8. So my two numbers that I've had to find are 8 and 9. So just double check. When we add them, do we get 17? Yes, we do. 9 add 8 is 17. And 9 take away 8 is 1. Now, I know when the questions are this easy, you can probably just do it by trial and error. You can just fiddle around in your head and work out what the numbers must be by trial and error. But it would be great if you just don't do that. So you try and get used to the whole process of constructing and solving a simultaneous equation. But obviously check your answers at the end. So that's what the first 2 or 3 questions are like when you do this Hegarty exercise. And then the other type of question that crops up is like this. Okay, so 3 donuts and 2 cakes all together cost £7. 5 donuts and 4 cakes cost 13. Find the cost of a donut, find the cost of a cake. So let's just go and construct some equations for this. So I'm going to use D for donuts and C for cakes. So I know that 3 donuts plus 2 cakes equals £7. Just the top sentence. And then my second sentence is telling me that 5 donuts plus 4 cakes equals £13. So there you go. You constructed 2 simultaneous equations. Now I can't just add these together or subtract them yet because I don't have either the C's or the D's having the same numerical value. So if I call this equation 1 and I call this equation 2, I can see that if I go and double equation 1, I will get 4C, and then I can go and just do something with the other equation because that's also got 4C. So let's go and take equation 1 and double it. So doubling the 3D, doubling the 2C, and doubling the 7, and I'm going to get 6D plus 4C equals 14. Okay, I've just doubled the 3 terms. Now, if I go and bring equation number 2 across and just write that underneath it, 5D plus 4C equals 13. I've now got 4C in each of those 2 equations. Now, am I going to add those equations together to get rid of the 4C's? Well, no, I'm not. If I go and add them together, I'm going to get 4C plus 4C, which is 8C. I don't want any C, so I'm going to choose to subtract the bottom equation from the top one. So when I go and subtract the blue one from the purple one, I get D equaling 1. Okay, so I know that the cost of a donut is £1. Now, as always, my final step to work out the other variable, on this occasion C, is to take either of the equations I started with. So I'm going to take the top one. I know that 3 donuts plus 2 cakes equals 7, but I've just worked out that D is 1. So I can go and replace that D with 1. So 3 lots of 1 are 3, it's 3. So 3 plus 2 cakes equals 7. Take away 3 from both sides. I get 2C equaling 4. And then halving both sides, I get C equaling 2. So I know that the cost of a cake is £2. The cost of a donut is £1. And then before you go and put your answers into Hegarty, check that they work. So 3 donuts, that's 3, and 2 lots of 2, yes, that does give me 7. And the second sentence, 5 donuts, that's 5 lots of £1, which is 5, plus 4 lots of 2, which is 8. 5 plus 8 does indeed equal 13. So that's it, folks. All right. I want you, please, to go and do number 195, please. I've set it all up for you on Hegarty. So if you could go and do that now, I will keep an eye on any posts you might be sending across. And I will also be looking at your marks. And once your marks are good, I will transfer those across over into my remote mark book. As I said at the beginning, I think some of you would probably find this particular exercise easier than the other 2. So please do take the opportunity. If you rattle through this really quickly, can you just use your remaining time to go back and try and get a mark on either of the other 2 we've done before, please? Or improve your mark if you've already got marks. Okay, guys, so that's it from me. So I'm just stopping the recording.